we'll send it to you, the better one.
Okay, that's good.
All right. Are you guys ready to begin?
Yeah, anytime.
Yeah.
You guys are ready to begin, we'll go for it.
Okay.
Let me start this and then go full screen. There we go. I am ready.
Okay. Good morning, everyone. We are going to give our final presentation for the NDSU Industrial Engineering Capstone course in the spring of 2020. Our project was in collaboration with ComDel Innovation and Heartland Precision. An overview of our agenda for this presentation, we will begin by introducing the project team and going over the company and our project plan. And then we will go into the layout changes that we're recommending based on the problem and some other improvements that we noticed while we were visiting ComDel. Then finally, we'll look at the simulation data and cost justifications that we used to make these recommendations and conclude with an implementation plan of how we recommend that they implement these changes. And then the picture on the right is of some bolts that ComDel manufactures, and our project is revolving around their metal finishing process of these bolts. The project team consists of me, Darby Beyer, an industrial engineering and management student graduating in December. Also, we have Thomas Sprengeler, who is an industrial engineering student graduating this May, and he's already began his master's program in mechanical engineering. And then also Jacob Tweeten is the final member of our student team. He's an industrial engineering major graduating in December as well. And then we also wanted to note that Justin Baker was our project sponsor. He is a project manager at ComDel Innovation with a background in chemical engineering.
All right, so a little overview. ComDel Innovation and Heartland Precision is a company located in Wapaton, North Dakota that began as a 3M manufacturing plant. Over the years, the plant was very successful, but 3M eventually shut it down and was bought by few of the employees with a new idea of commitment to delivering innovation. Thus, ComDel Innovation begins. They now focus on the production of medical equipment, hydraulic pistons, precision manufacturing for various industries, as well as high-quality production of U-bolts, federal ammunition bullet slugs, and many other items. They also specialize in contract manufacturing, where they will manufacture limited runs of items for different companies that cannot manufacture it themselves. Our goal as a group was to improve the productivity and workflow of the U-bolt manufacturing. The scope of our project was to improve material handling for the U-bolts in the metal finishing process and set out to make recommendations to the coating line, creating better efficiency. Our group's expectations were to A, map out the current as-is process between the metal finishing and upstream steps. B, evaluate the current process and identify areas of improvement. C, make recommendations based on our discoveries. D, create a new 2B process model. And lastly, perform an ROI and cost-benefit analysis on the new process.
So to start this project off, we had 5 preliminary constraints that we kind of had to follow the entire time. And that is cost, available work area, amount of labor available, amount of plating racks available, and the required time to plate each U-bolt.
Based on our statement of work, we came up with 4 deliverables that we would provide to ComDel. The first being a current state model. So we simulated their current process using Arena software, and we also made layouts of the current work areas. We then developed recommendations of our design changes that we believe would improve their process, as well as some possible future improvements beyond this project. Next, we made a new process model, so a new state simulation to show how the improvements would work in their process, as well as new layouts to show the changes that we're recommending. And finally, we provided them with an ROI and cost benefit to justify the work that we're recommending and show the financial impact to their company. The timeline for this project began in mid-January at the beginning of the spring semester. And we met with ComDel to discuss what the project scope would be. And then we are completing the project this week at the end of April, and the project was completed all on time.
So next we have the process flow chart. So this is going to be the overview of the entire process that we were working with. So if we start in the first gray box there. So right there, U-bolts are bent and then stored in gaylords until they get to the plating process. Then from there, in the yellow, the worker loads the U-bolts onto racks, and then these racks are picked up by a robotic machine that then sets them into the plating process. And then from there, they go through the plating process, and once they're done, the robotic arm will pick them out of the plating process and set them back down in front of the worker. And then from there, he will use a compressed air gun to blow dry all the parts off. He takes the parts to quality control. If they pass, they continue on. If the parts are failed, they go back into the gaylords and wait with the other ones until they can go back through the process again. If they are good, though, the worker will unload all of the U-bolts off the rack, and then he either counts them into special order bins for John Deere. It's about 12 U-bolts a bin, or they'll go into a general shipping gaylord that holds about 250 and then just gets sent off to shipping, and then they do with it what they need to.
So there are three main problems that we found. First, being loading time. Time and money is being lost because employees must manually untangle and remove bolts from one another and place them onto the plating rack, which is being demonstrated in the picture. Right now, the goal set by management is aiming to get 4-minute cycle times for these bolts. Another obstacle faced was the variety of parts the machine in the upper right was producing, which was 51 different size A, L, and U bolts. Because of the variety of the production, we expanded our ideas to ensure the coating line was able to plate all parts the facility could produce. The final problem encountered was the special order parts, which were dispersed and placed into smaller bins following the plating. Problem with these parts were often miscounted due to the desire to get parts out as fast as possible. Going into our layout, after reviewing some time studies and watching the loading process, we came up with a few recommendations for the layout and station design. Our recommendations are to move the unfinished bolts to a height of 40 inches, which will reduce the bending and back strain of the coating worker. We also suggest to remove the special order counting station to a separate workstation. This will reduce the loading time as well as the need for the worker to leave their station at the plating rack. Moving the counting station will also result in fewer miscounts of the bolts and ultimately reduce the stress of the employee. Finally, we recommend moving the unfinished bolts to the right-hand side of the plating rack. Ergonomically, this is going to eliminate the need for the employee to turn 180 degrees to collect their parts from the gaylord. Right now, if an employee that turns 3 times during the loading process means that they are turning 225 times during the shift. By moving these parts, this will reduce the loading time and also minimize any strain or muscle fatigue the worker could have. Shown is the current layout workstation. As you can see, the employee must turn multiple times and walk numerous feet in total to get to the station of desire. These distances have been mapped out and shown on the right there. We see the longest distance being traveled is to that special order counting station, which was just another justification for us to move that station. Here is the recommended layout we've created to best utilize the employee through the reduction of unloading time at the coating station. With this design, the worker will not need to leave their station at the plating rack, resulting in 174 feet saved, which turns out to be 3.2 minutes saved an hour. Again, moving the counting station will result in fewer miscounts of the bolts, and as previously mentioned and also shown here, we've moved the unfinished bolts to the right-hand side of the coating rack. All in all, we're anticipating more efficient production of bolts with this layout design. Here is a comparison of the two layouts just discussed. In the new layout, you will also see a design created for the special order part station, which is now going to be located in the shipping room. This station will consist of a scale to help with the counting of bolts, as well as designated spots for finished and unfinished U-bolts. The task of the county special order parts is now going to be done by the shipping employee, saving time during the loading process. And because there is already a shipping employee double checking the accuracy of the special order parts, we came to the conclusion that minimal time would be added to the shipper workers' original task.
So the next section is going to be all of our other improvements. So for the first improvement, it's going to consist of the tote layering system. So here, the current state, U-bolts are falling off the conveyor into a large tote. And then from there, the worker has to adjust a metal sheet in the tote to help spread out the U-bolts so they don't all pile up in the middle. And the problem here is when the U-bolts all fall into these big gaylords, as you can see in the picture, they become quite tangled. And so once they get to the workstation where the worker is pulling the U-bolts out and loading them onto the racks, it's taking a lot of extra time to go through and pull out all of the U-bolts, untangle them one by one, and then load them. So like you can see in the top picture on the right-hand side, the worker spends a lot of his free time or any time in between racks going into the plating machine. He sits there and pulls out bolts and organizes them on the edge of the gaylord right there to get them ready for the next one. And so what we recommend when that worker goes around and moves that metal plate to kind of spread out the U-bolts in the tote, instead of just doing that, we propose that he uses either corrugated cardboard or corrugated plastic separators that he places in the gaylords every time he adjusts that plate. And then this way it creates a layer of separation, like you can see in the bottom left picture, a layer of separation between all of the U-bolts. And then what we hope is that this creates a separation between roughly every 50 U-bolts, which will make less tangling of U-bolts and easier and faster handling for the worker that is going to be dealing with these parts. And then upon further analysis, we concluded that this method of layering is not going to reduce the capacity to a point where it's going to affect the process. So then our next recommendation is going to be our machine vision quality control. So for this, the current system is very time consuming. The worker has to spin on a thread checker onto both sides of the threads of the U-bolts to make sure that they all pass quality control. And then he's also using a light sensor that checks the thickness and the color of the coating. And so this is taking him roughly 45 seconds to a minute to complete every rack. And so this is a lot of wasted time that we think we could make a lot quicker. And so what we propose is a jig system and a camera setup that is connected to the computer at the station, where the worker can pull the U-bolt off of the jig or off of the rack, set it in the jig, flip it over so it can take pictures of both sides of the threading, so you get a 360-degree view, and then that information gets automatically uploaded into the computer for any future data analysis and current system tracking. And then all he has to do once he flips the part over in the jig is take the light sensor, set it on the U-bolt, and then he's good to go. And then all this data will automatically be stored in the computer. So then he does not need to go and spend any excess time entering this data in. So the only downside with this proposal is that it does not include an option to also take care of the zinc coating thickness. That's still going to have to be done by hand, but we still think that this will be a pretty drastic improvement on the current system. So next is our simulation. So for our simulation, we had a few assumptions. Both plating lines are running at 2 12-hour shifts a day, so 24 hours a day. There is always a backstock of unfinished bolts. The forming machine outputs U-bolts at a much faster rate than they can plate in the plating machine. Each line has only one available worker at any given time, and we are plating bolts in batches of 64. That's an average size between an average size batch between all of the different sizes of U-bolts.
So we first started with our current state simulation. We found that the throughput in our simulation was about 7.202 racks per hour. And we compared all the simulation data to the data that our project sponsor was able to send us from a couple weeks of the plating line running, so that we were able to verify these numbers and ensure that our simulation was accurately depicting their current process. So some of the main load times or the main process times were that the load time is currently taking a little over 2 minutes, and that is just the worker grabbing individual bolts out of the Gaylord and putting them onto the plating rack. The unloading time is taking about a little over a minute, and that is due to having to sort out the special order parts. And then the quality control time, as Thomas talked about, is just under a minute. And we're planning to drastically decrease that with the automated vision tracking. With all of our simulations, we used quality control at a pass rate of 95%. That was an average given to us by ComDel for their general pass rate on bolts. You can see in the chart over here that the company does have a goal of 10 racks per hour, so we are just about 3 racks per hour short of that on line 1. And then I also included that there are about 12 racks in the system, so in the plating line at a time, whereas they would like to get up to a max of 14 racks in the plating line at a time, because that would be pushing bolts through at a much higher rate. And then I just quantified the bolts per rack on the output on the far right. So if they were running at their desired 10 racks per hour, they would be putting out 15,000 bolts a day, and are currently running about 4,500 bolts a day short of that due to not being as efficient as they would like. So moving on into our new process model. So we made estimates on the amount of time that each of our improvements would save in the different parts of the process, and we're able to simulate that the new system would likely have an output of 8.5 racks per hour. So still a little bit short of their goal of 10, but much improved from 7 racks per hour. You can see that the load time was decreased by the layering system. The unload time was greatly decreased by moving the special order parts to the shipping worker, and the quality control time was greatly reduced by the automated the vision system used to perform the quality control. We also used in this simulation 14 racks efficiency in the plating line because the worker is going to be much more efficient and having racks ready to go all the time for the automated plating line to take those racks in. So the output difference here between their desired output and what they would be able to produce with this new process is 2,300 bolts short of their goal. Moving into the cost analysis, looking at our design, so the improvements that we discussed, each of those improvements would save a certain amount of time in the process, and we quantified that time as a 21% increase in bolt output per day, or a 21% time savings. Additionally, the ergonomics changes would potentially eliminate workplace injuries, and each workplace injury of a back nature within manufacturing can cost the company from $40,000 to $80,000. So that could easily be a very big cost savings if we were to prevent an injury. And then looking at the charts on the right, one of the best ways to show how they're saving money through this increased efficiency is the cost to plate per rack. So we know from the company that it costs $225 an hour roughly to run the plating line, including worker labor. And so the more racks that you can get through per hour, the less it costs per rack to do the plating. And so our changes would reduce the cost from $32 a rack to $26.50 a rack. So that's a great cost savings per bolt. The cost of our recommendations altogether would be roughly $3,900. So not a very big capital investment for this company to reduce the worker time by over a minute. And then you can see the production cost to produce 15,000 bolts. So their goal of bolts would be reduced from $7,700 to $6,300. We also went ahead and put together an analysis for future automation. So beyond the scope of this project, if they were to consider adding perhaps a robotic arm to greatly improve the efficiency of the plating racks, the throughput would be 9.8 racks per hour, so basically at their 10 racks per hour goal. And that would be mostly due to a decrease in the loading time. We used a basic robotic arm model that costs $35,000. However, we would have to put in some costs to the time to programming this arm. And the main thing to note about this simulation was that in order to keep up with the efficiency of having a robotic arm for the loading process, the automated plating line would have to be able to handle up to 16 racks at a time. So when you increase the efficiency of having the robotic arm, the bottleneck becomes the plating rack itself and the time that it takes to plate each bolt. So they would have to work on the efficiency of the plating line before this would become beneficial. And you can see that it would increase bolt production by 15% as compared to our previous design, which is a 40% increase from the current state.
So next we have the recommendations, and here we recommend implementation of this in 3 stages. So the first stage is layout and ergonomics. So for this, we're going to move the special parts sorting to the shipping area, switch positions of raw material and rack loading, resulting in less movement for the worker, increase height of raw material tote to 40 inches to reduce back strain. And then next in stage 2 will be tote layering. So this will be another simple change they can make. Is pretty cost effective, and so for this they're going to implement the proposed layering system in totes to reduce material handling time of the worker. The next step, stage 3, is going to be a little bit more costly, and this is going to be the implementation of the machine vision setup for checking U-bolt parameters such as correct length threading and shape of U-bolt. Then once all of this is done, a possible stage 4 would be future automation and the incorporation of a robotic arm to help orientate, collect, and sort the U-bolts that are coming off of the Gaylord and getting loaded into the plating racks. So lastly, our conclusion. So we have the current state models, which we've completed and tested for accuracy, our recommendations, which are our layout, tote design, and workstation design. And we have our new process model, which we completed, and new numbers were analyzed with our simulation. And then from there, we used the numbers from the simulation to put together ROI and cost benefit analysis for all of our different options and justifications. Any questions?
Of course I do. Very good presentation, the 3 of you. That was well done. Just a couple questions. So from an industrial engineering standpoint, if you were the owner down there, how would you rate this feasibility? Would it be something you would do right away? Is it something that they can, and I like when you ended up and you said, here's the implementation plan, phase 1, 2, 3.
Yep.
If you were the engineer down there, how soon would you take off on this project? Is it that beneficial, do you believe?
One of my favorite things about this is that the implementation, I think, is very feasible, just in the fact that a lot of this stuff, if you look back into a lot of the history of a lot of different companies, the implementation of similar type things are very, very cost effective and do really make a difference. Like the ergonomics and the layout and some of these simple changes can have a drastic effect on the process without costing the company hundreds of thousands of dollars. So I believe, yeah, it's very feasible for like very quick implementation.
How receptive do you think the workers would be for the change in layout of the initial workstation?
Uh, um, that's something that was brought up during the ComDel presentation when we gave it to the company. There was a girl there that was saying that some people like their layout like as preferred, like it might change depending on the worker. But I would probably suggest just giving it a shot, seeing if it would help them out. I think they'd kind of be open to it if it like kind of saves them on some muscle fatigue or anything like that.
Okay. So were you able to test any of the layering that you proposed in the bin?
Unfortunately, we weren't able to get back down to ComDel in the second half of the semester due to the COVID-19 situation. So we did not get to test that, which was one of our kind of biggest regrets in this project, is we did want to test those more thoroughly to make sure that our estimates of time savings were as accurate as possible. But we did not get to complete testing on this.
And that was something that management thought was very, very worthwhile if they were to layer that. They thought that was a good solution.
Yeah, they seem to really like that solution. One of the original proposals was going to be the sole use of the sole recommendation of using cardboard, and that's one thing. Talking with them, we realized that a lot of companies aren't going to like the cardboard side of it just because of the wastefulness, and so working with them, we came up with with also doing the option of the corrugated plastic separators too, something that might be able to last longer and isn't going to be thrown out every day. And so we worked with them kind of a little bit on the design of this, and they seem to be really receptive to it.
Okay. Moving into the machine vision QC, do they use any machine vision QC right now in their plant?
They do use machine vision in some areas, but it's not as widely used as it is in some factories. And that machine vision for the quality control is actually something Justin has thought of before, but he said he never put a ton of time into trying to set up a system. Some of their main concerns were the coloring of the parts, if they were dirty, clean, because they kind of all come out differently. And so I was working with the company on that and kind of going through some of the systems and some of the abilities of the systems to use color contrasting to kind of pick the dirty parts out and the clean parts out and still be able to do the quality control on all of them. And so I think they really liked some of the final stuff that we were able to present to them with that.
Okay. The robot arm, do they use any robotics down there already? Because you propose a robot.
Yes.
Yeah, they do. And one of the robotic arm that we actually recommended to them, they have, and we got to see one there. They were using it for a different type of manufacturing, but they had the identical robot there doing all of their own programming and end effector work, creating the head on the robot. So that was a plus for for the recommendation of that robotic arm.
Okay. Well, it sounds like you guys had a good experience down there. It sounds like a very progressive company, and they've done a lot of stuff down there. I've heard a lot of good things about the plant too. Very progressive. I'm not afraid to kind of reach out and do some new stuff and try some new things. So I think you've given them some good numbers. You've given them some good ideas, and it wouldn't surprise me if fall or a year from now they might implement some of this. It might be worthwhile. I know that a couple of you, I think Darby, you graduate in December. I think Thomas, you're done next spring or whatever.
Yep.
Probably wouldn't be a bad idea to contact with them in the fall or something, and when things get back to normal, and make a visit down there and see if they've done anything or what they've done.
Okay.
Be worthwhile, I think, because it sounds like a very progressive company. I kind of like that, and I hope they had a good experience with the sponsor again, and it sounds like they did. So
Yeah.
Yeah, they're
okay.
great to work with.
I don't have any other. Yep, I don't have any other questions. You said you already gave their presentation to them already this week or last
Yep.
week? Okay. So all you'll need to do is I got a copy of your presentation. The final report is due next Friday by the end of the day. So that's all I need from you. Other than that, publish the recording of the presentation, and then hopefully I can get that to a couple of the faculty and a couple of judges that I have picked up, and we'll get
Okay.
that back around and do some judging, and then we'll get back to you, if not the end of next week, the following week after, with some idea of where the awards will go to. Okay?
Okay. Sounds good.
Anything else? Thanks, group.
Thank you.
Thank you.
Bye.
Bye.